Okay, a definite integral this time. That does add a couple extra steps, but they're pretty minor and they're nothing too surprising. The substitution here is so simple that it almost feels unnecessary, but if you can do one and you can say that u is x plus 1. I don't want the square root included in the u because then the derivative gets a little complicated. This is a nice substitution because du ends up being the same as dx. So we kind of get rid of this 1 for free when we do it this way. So what we get after this is integral root x plus 1 becomes root u, or just u to the 1/2. We know power rule is coming up, so we might as well prepare for it. Dx we can just replace with du, right? So we've got this got replaced with u, this got replaced with du. All that is good. Now, when we do this antiderivative, the power of, oops, sorry, I shouldn't have an integral sign anymore. The power of u goes up by 1, so it becomes 3 over 2. We multiply by the reciprocal of that. We add, I was going to say we add c, but because it's a definite integral, there's no point, so never mind, no c. And now we need to evaluate that at our upper bound and lower bound. And here's where the new step comes in. We are not going to be integrating from 0 to 3 anymore, because these values in the original integral were for x. These technically could read x equals 3 and x equals 0. When you make a substitution, you're changing the variable. You change the limits of integration when you do that. And if you don't update them, if you forget to update them, then trouble will ensue. So it's easy to make the switch. We just have to calculate these new limits in terms of u. U, it says here, is x plus 1. So if x is 3 for our upper limit, u is going to be 3 plus 1, u will be 4. For our lower limit, x is 0. 0 plus 1 means our u is 1. So while the original integral went from 0 up to 3, the new integral goes from 1 up to 4 because of the substitution we made. If your substitution is more complicated, then you might have to do a little more complicated crunch to find your new limits, but you can do it. These are the new limits that you'd use. So we can use these limits and say we're evaluating this at 4 and at 1. And if we do, we get 2/3 of 4 to the 3 over 2 minus 2/3 of 1 to the 3 over 2. 4 to the third is 64. Square root of that is 8. 2/3 of that is 16 over 3. Minus 1 to any power is 1 times 2/3 is 2/3. 16/3 minus 2/3 is 14/3. So that's one way that we can complete this integral. We can stay with our u, update the limits of integration, and get an answer that way. Now, you're probably thinking, or maybe you're thinking, what happened to reverting? And yes, you can absolutely revert this and get the same answer. If you're here, you get 2/3 u to the 3 over 2. You could, at that point, switch back, like we've been doing with all our other examples. U is x plus 1 to the 3 over 2. And now you can evaluate using your x limits of integration. The original went from 0 to 3. We can use those, and look what happens. We get 3 plus 1 is 4. So 4 to the 3 over 2. And then if we plug 0 into this, we get 2/3 of 0 plus 1 to the 3 over 2. You can see this is coming out the exact same way as the previous one, and you still get 14/3. So what this example is to show you is you can do your integral, revert back to the original variables, and do the integral and everything comes out fine. Or you can stay with your substituted variable. In this case, you could stay with u and not switch back. But if you choose to do that, you must remember to update your limits of integration. If you do that, you'll get the right answer. If you forget to update your limits, bad things will happen.